4.2 trigonometric functions, the unit circle. These are the objectives. You can pause to read them, but I'm going to be going to the next slide. This is the vocabulary key concepts that you should know by the end of the section. You can pause, but I'm moving on to the next slide. Definition of trigonometric ratios. Let me read this to you. It says, let t be a real number and let xy be the point on the unit circle corresponding to t. So basically what this is saying is that you have a point here, and this is distance t, and this point xy in the unit circle is defined as follows. Sine of t is equal to the y value of the point. T again represents the portion of the circumference of the circle, which is what we call in radians. Cosine of t is equal to x, tangent of t is equal to y over x. And then notice that these cosecant, secant, and cotangent, these are new. Cosecant, secant, cotangent of angle t, they're the reciprocals of what you see on the left hand side. Now a little technicality here, x cannot equal 0 and so forth here, otherwise we have undefined. Next slide. Let's make an extension of this definition. What would happen if instead of looking at radians, let's look at degrees. So instead of going along the circumference circle, we look at this angle theta. Well, it turns out that the coordinate value for sine of theta is also just going to be the y value, given that we're in the unit circle. The cosine of theta is just going to be the x value, and so forth. So keep that in mind, because we're going to be using that. It says determine the exact values of the 6 trigonometric functions of the angle theta. Here's the angle they're talking about, angle theta. So to find the sine of this angle, all we need to do is give the y value. Cosine of this angle is the x value. Tangent is y over x. Some pre-algebra here, and that's how we end up with 5/12. To find the cosecant, secant, and cotangent is basically the reciprocal, so what you see on the left. It's pretty straightforward. Let's move on to the next slide. Same manner, says determine the exact values of the 6 trigonometric functions of the angle theta. So now this angle opens a little bit more. Now we're on the third quadrant, but it's the same idea. Same principle. Sine of the theta is just the y value. Cosine of the theta is the x value. Tangent is y over x. Pre-algebra, notice that we end up with positive 3/4. Cosecant reciprocal, secant reciprocal, cosine, cotangent is 4/3. Moving on to the next slide. The unit circle. By now you start getting familiar how to generate everything on the unit circle. And we're going to be using this throughout this section. It says find the point xy on the unit circle that corresponds to the real number t. Let's bring up the unit circle, make this a little bit easier, but you're going to have to memorize this eventually, and you should be able to do this problem without looking at the unit circle. So the point that corresponds to 5 pi over 4, notice that, let me see, 5 pi over 4, go around the unit circle all the way to 5 pi over 4, so we're here. So the point xy that corresponds to this angle is negative radical 2 over 2, comma, negative radical 2 over 2. For the t value of negative 4 pi over 3, since we want negative 4 pi over 3, we want to go negative 4 pi over 3 this way, and notice that we're going to end up terminal with 2 pi over 3. So the coordinate value for negative 4 pi over 3 is negative 1/2, comma, radical 3 over 2. It says evaluate, if possible, the sine, cosine, and tangent of the real number. So they give you the t-value of 11 pi over 6. So you know that we are here. This is your radian measure, and you want to give me the sine, cosine, and tangent. The sine is basically just going to be the y value that, well, this is the coordinate value. The y value of this point is going to be the sine, which is negative 1/2. The cosine is going to be the x value of this point, which is radical 3 over 2. Tangent is y over x. You have to do a little bit of rationalizing denominators here, but you should have no problems coming up with this. If you do, talk to me in class. It says evaluate, if possible, the sine, cosine, and tangent of the real number t, very similar to the previous example. So now we're looking at negative pi over 2. So we are here. Notice this coterminal to this angle. The coordinate value is 0, negative 1. So we look for the sine, which is just the y value. We look for the cosine, which is just the x value. And the tangent is going to be the y over x. We're going to run into a little bit of problems here because we're going to have 0 in the denominator. So you know that this is undefined. That's what we have, if possible. Moving on to the next slide. I'm going to explain to you even and odd trigonometric functions. Let's begin with even functions. This is going to be a little bit confusing, but if you look at this example, it should make sense. I mean, this explanation, it should make sense. We're going to be using the unit circle to better understand what this represents. What it represents to be an even function. So this is what we're going to do. We're going to let the t-value equal 11 pi over 6. Once we let the t-value pi over 6, I'm going to be looking at this one. I'm going to compute cosine of negative t. Cosine of negative pi over 6 will end up on the fourth quadrant, coterminal with 11 pi over 6. So that's how we end up with radical 3 over 2. Now I'm going to do the right-hand side, cosine of t. We should end up with the same thing. This is what the formula is saying. So we compute cosine of pi over 6. Cosine of pi over 6 is radical 3 over 2. These values are the same. The formula tells us to, but this is why it happens. Why this is equal. This is why we call this an even function. I'm not going to show you an example for this one, but it's very similar to cosine, this part. Let's move on to the odd functions. And again, I'm going to be looking at the unit circle to better understand what this means. Let's look at this one. So let's pick a t-value. I'm going to pick 5 pi over 6. This is positive 5 pi over 6. Since we're looking at negative 5 pi over 6, you know that we are here. And we're looking at cosecant, which is the reciprocal of this. That's why cosecant of negative 5 pi over 6 is the reciprocal of negative 1/2, which is just positive, negative 2. Then, this is the left side. Now let's look at the right side. This is negative cosecant of 5 pi over 6. So 5 pi over 6 cosecant. Here's cosecant, the reciprocal of 1/2, which is 2, but we're multiplying this by negative 1, which is right here, and that's how we end up with 2. These two values are the same. This is basically what it means to be an odd function. Moving on to the next, and the same. You can do the same thing for the other ones, and you end up with this statement, this equality.